What's up, everybody? Welcome to the Jake Fletcher Show. Super excited to bring you guys this episode here. We have Brandon Steinbrecher with Symbiotic 3D, which is a home building company unlike your traditional home building company. And we're going to be talking about 3D home building today, involving 3D printing of concrete, of glass, and who knows what else we'll jump into here today. I'm super excited. I've been nerding out for the past couple weeks since we booked this. So how are you doing today, Brandon?
Oh, pretty good, man. Thanks for having me, man. It's really good to see you again. And really look forward to diving in. It's such a interesting topic, and the way that it's developed over the last couple of years has been profound. So.
Yeah, it's incredibly interesting, both in the practical sense and also for nerds like myself, diving into the science behind it and the implications for the future of humanity, the future of the technology itself, how things have developed and kind of where things are heading. And there's a lot of really smart people working on in this field of 3D printing. And we're going to jump into it and talk about all of it. So, well, a lot of it. So first and foremost, give our listeners and if they're on YouTube, our viewers, a little background on yourself, background on Symbiotic 3D and how you got involved with them.
Yeah, for sure. Well, I know we're going to be talking about 3D printing and concrete. I actually am a carpenter and an artist. And so I used to do a lot of designs. I still do. It's kind of like my outlet for events, music festivals, and stuff like that. We do a bunch of creative installs. But my movement into learning how to use different mediums has always interested me. And I started to learn how to create aircrete, and it's kind of a cement blend. And I had a little experience creating some forms and working on creating a geodome in Florida. And so through my artistic venture at a music festival, actually, our art team was collaborating with another art team that was working there. And I met a good friend named John Ripley. And he's actually one of the owners of Symbiotic 3D, as well as his good friend Evan. And so I met them then, and we worked together, and they saw our work and we saw theirs. And we've always been in touch, so that leads me here to be out here on his property out here in Utah, and we're kind of out in the middle of the desert, and we now have Symbiotic kind of getting its legs going, and we're going to start printing houses here on our property to create kind of a little community for ourselves and to start moving forward with creating a sustainable future for everybody.
That's awesome. So what's your role at Symbiotic?
At the moment, it's kind of learning how to orchestrate the whole entire process. So we're manning the entire process ourselves, from mixing our solution into the hopper and then it going into our sled, into our mixer and getting mixed down, and then it gets pumped to the machine and then it's being fed out. So there's a couple different stations that operate that whole procedure. And I'm usually in the process of watching the actual structure become printed. And, you have to have someone that has eyes on making sure that our consistency is remaining the same. When you're printing over a 12-hour period, the humidity, the temperature is going to change and fluctuate throughout the day. So learning how to, add more rapid set, or learning how to create a more viable material as it comes out the machine throughout the day, and kind of setting those systems in place so that way when we're ready to expand, we can kind of really get some things flowing. So that's kind of my job, is learning a little bit of everything. And being able to help organize those different positions. And I'm the aircrete specialist of our team. So I've been teaching the crew how to create aircrete and its different densities and how to work with it. Yeah.
That's super interesting, man. And so when talking about home building, this is, 3D printing in general is when you look at the vast span of history of building materials, I mean, humans have been building things presumably since we came out of the trees and started walking on two legs and needed a place to stay. So in the vast history of building materials, this is very new on that linear progression, as is just 3D printing in general. So you have modular home building, you have container homes made out of shipping containers, prefabricated home building or prefab homes, light gauge steel, usually used more for like commercial applications, I guess you could say. And then of course you have traditional like stick framing home building. So why 3D printing? What benefits does 3D printing of homes give us that these other methods don't? And what makes it the best choice? And is it the best choice?
Yeah, well, from a financial and structural standpoint, I would say that having something in concrete, is going to stand the test of time against, your traditional wood structure or metal housing, with the wear. It's also depending on the environment that you're living in and your house is in. The one really amazing thing that we've been realizing working with the concrete is that it'll not only stand the test of time, but we are able to create forms and shapes that you normally wouldn't be able to create by hand. So whether we're working with a dome shape or more of a curved edge wall, we can work with the natural environment. So that way in areas, like Louisiana or in Florida, where there's a lot of hurricanes, and we're able to, make the home more geodesic to create more of a larger strength integrity for the building, and it'll hold up against certain storms and stuff like that, or flooding. Your house isn't going to float away or get damaged or rot from it being floating. All your things inside will, but the structure itself will be sound. And that's just from, like a safety thing. Like you said, we've been developing things for safety ever since we could get out of trees. So it's all about protecting ourselves. And so to have something that's that hard of a foundation is really important. And then just the cost alone, having someone build and having a team of builders there to produce a timber frame home in the materials that you're buying, and not only to speak on like a planetary sense of all the wood that we're using and like all this insulation that we're creating, when we can 3D print something on a crew of 10 people, and then we can insulate. So even if your house is bigger than our 20 by 20 set, we can move the printer as we go because it's on wheels. And that way, when we pour our aircrete, which will be the lining that goes in between the interior and exterior wall, per foot has an R value, can't quote me on this, but I think it's something like 29, which is higher than your standard R value insulation that you put inside your walls, which is like, full fiberglass and all this other stuff. And then the aircrete itself will make the structure more monolithic. So if there's any breaks or seams, it'll fill everything together as one structure and make your building one monolithic thing, which is, incredible. So in just those two things alone, and then in artistic sense, there's certain values to how far of a grade we can bring something out, as it's drying before it starts to collapse. But other than that, your possibilities are limitless to create amazing homes and designs and features that you normally wouldn't necessarily be able to do.
That's awesome. It's such a combination of so many amazing things, and there's different materials too. You can 3D print with concrete, with glass, with wood. I've read about other substrates. There's metal, carbon fiber, expanding foams, microfluidics, which I don't even really understand yet what that is. And of course, you have all the different various like plastics and rubbers and different levels of those types of materials. Is there any material that as of now can't be 3D printed, so to speak?
Oh man, I mean, I'm sure that there definitely is, but I mean, has someone put enough time and energy into trying to print it? Probably not. Um, but yeah, I mean, we print everything. I mean, I've got a regular printer set up in my room that prints and designs, some of our stuff in plastic. Um, just for like that's like a part of a hydroponic setup for us to like create more green vegetables. So like 3D printing is so dynamic in what it can do. But yeah, speaking of all these different materials, um, the direction that we're trying to move forward in is learning how to create our own geopolymer. So, for example, like the soil content that's out here in Utah is very dry, very sandy. And once you get down, it's very hard, sandstone. So learning how to take, per se, for simplicity, a 5-gallon bucket of dirt from any place, break that down into its formula of chemicals, and be able to know exactly what we need to add to the substrate that is around us to create a geopolymer that we can print and create a home out of.
That's awesome. I actually, that was something I was going to ask you about, which I think is one of the most exciting aspects of 3D home building is printing with on-site materials. So it seems you guys are utilizing that or working towards being able to utilize that method of construction. What are the pros and cons of that, assuming that the on-site materials are viable to use, and describe a little bit that process of you kind of alluded to like the analyzation of the substrate to figure out what needs to be added or maybe subtracted. I don't know. Give us a little insight on how that works and the pros and cons.
Yeah, so the pros would be huge. Just the fact that we can go anywhere in the world and be able to just scoop dirt out that needs to be, it might even need to be removed or displaced from one area to another. And just being able to use that and be able to create homes is, amazing. We're no longer transporting materials or harvesting, Portland cement or like creating cement. So the benefits are astronomical. I'm not necessarily a molecular biologist or, I dabble in chemistry, like organic chemistry a little bit, and that's kind of what got me my curiosity into this, even though, JR and Evan have already been kind of diving into this and having some pressure tests done. So there's a lot of variables that have to be considered, especially in a building. So we're learning to, our mixture right now is kind of like your standard Portland cement mixture, other than, we're creating different ratios of things to create more elasticity or faster dry time, like so it's setting more rapidly. And so for our natural clay, I think every environmental feature, even in just the United States, will be drastically different. And I think that'll be the biggest challenge. There's this huge opportunity and this huge gold mine for unlimited resources, but there's a very tight door to fit through of like, how do we solve these equations for all these different places? So all of them are going to be drastically different, and learning how to feed these through our machines, it's quite the process. Just learning how to keep something the same consistency that it's actually able to pump, but it's not wet enough that it's not going to fold and fall under pressure. So I don't know. We've just barely dived into that, and it's a very complicated thing, and it's way above my chemistry level. But we've got the people, and we're looking for other people to continue helping develop that.
It seems like it's kind of like the adult version of when you're a kid building a sandcastle on the beach, and like you have to get the sand just right. So it's like not too dry that it doesn't do anything for you, or not too wet that it just falls. It's like you have to get it just wet enough. So is that kind of a good analogy for the process and what it takes to build a structure?
Yeah. Yeah, I love analogies, but it's hard to find something that's comparable to, like, there's so many processes that happen as it goes. And But yes, it is very much like dealing with a sand-like consistency and learning how to just add a little bit more water or, a little bit more pressure or have it pump a little bit faster. So learning to make, our consistency the exact way that we want it.
That's interesting because I hadn't really thought about the production variables of like the pressure that it's pumping out or the speed, so to speak, as being obviously it makes sense that it's important, but immediately my mind more goes to like the material type and the mixture consistency and stuff like that. But the ability of the machine to do varying rates of like output or varying pressures and stuff seems to be of utmost importance, and having people on site there like yourself to kind of guide that, make sure it's happening correctly, I'm sure is also of equal importance. Can you describe to us like what's that process like, the actual printing process? Like what goes on from start to finish, if you can succinctly describe it, and how many people are on site? Is it the same machine for concrete and glass? And if so, if not, what are the different machines and how are those processes different?
Okay. Well, I'll first start by saying right now we don't print glass, which would be something that we want to look into, but I know that people have been doing it and it's pretty interesting. But yeah, we have a lot of our hands full with learning the concrete. So like a little bit of the process is we usually have a crew of about 6. Is probably the most minimal crew we can like really run on, maybe 5. But we're basically creating a very large mixture. We have a giant hopper that's mixing all the ingredients that we have in there, which is some Portland cement, baptizer, and a bunch of other little ingredients depending on what the humidity of the environment is, how hot or cold it is that day. And so we're getting all that mixed, and then we're actually filling individual canisters to a certain weight that we have set, or a limit that we have set in our bucket. And then we're actually mixing it in a cement mixer with a certain amount of water that we have predetermined. We have a very set thing that we start at. And as we start printing, we'll make minor adjustments. So as we make that mixture, we'll let it mix, and it dumps into an auger. And then it's a very specially designed machine, because not a lot of people are pumping concrete through hoses unless you're doing industrial concrete stuff. So we're then forcing this concrete into a tube, and then that tube is going up the top of our machine and down our hose. And then we have what your traditional 3D style, what today people think of, a box model 3D printer. So our computer then is off in the corner, and it's telling our X and our Y and our Z axis exactly what patterns and points to move to, and it also can control the rate and flow in which we're pumping. So once we get our concrete and our consistency going, we start pumping. We'll do a little test run, like a skirt, basically. If you're familiar with miniature model printing, you kind of print a barrier around the outside of where you're going to print to make sure that your consistency is good, to make sure that your layers are good. Because if you're putting more pressure, it's going to be pushing the ground more, or the layer below it, and that will fatten it out, fatten the layer, and make it wider. So we're trying to create layer consistency. And then, the process begins. And once we start, there's not, we could do a whole run and we could stop and start again. But stopping as easy as possible to our best benefit, to not create cold joints. So we are working on a system of, a 3-tiered system to create, 2-story buildings. Being able to fix the cold joint problem is nothing compared to like when you stop, and if your machine becomes jogged or off a little bit, resetting that and recalibrating that is very difficult. So especially on a machine that we're able to move and it's very modular, we've spent a lot of time, really honing that in and making sure that our machine operates at its maximum efficiency.
So let's say you like after you do like one layer around, because that's how 3D printing works. You do it in layers. Do you have to wait for that to dry before doing the next layer, or by the time you get back around, is it already dry? Or theoretically, it's
Yeah, theoretically, exactly. So when you're working, we've done it where we did blocks, different blocks. We've done whole structure. We let Habitat for Humanity use our structure, and they printed in the office actually in Salt Lake, and they did it as one go. And yeah, that's the hardest part is creating the consistency that is going to be wet enough coming through the tube, but when it makes contact with the ground and the air outside after it's been sitting for that one entire trip, that it's now dry enough to at least hold one more layer. So we've learned that our variable is within like 5 to 8 layers. Um, if you have 5 wet layers, where it's like, the air has maybe changed, or the temperature, the way the sun is heating wherever we are has changed, and things are coming out a little too wet, depending on the size, we've kind of learned like you can get away with 1 2 wet layer or 5 wet layers, depending on how big the structure is. But there's a limit to where, yeah, it will collapse, especially when you're doing straight, perfect lines. You're you're much more able to stack higher layers if they're wet. But who wants to just print regular buildings when we have the possibility to create some really beautiful curves and edges and change flux, so to make something more artistic and more natural.
yeah. I'm guessing based off of just my hunch that in more humid environments it would take longer to dry, and than it would in more arid climates. And so is that correct? First of all,
Yeah,
more or less.
yeah,
Yeah.
but you also want to make sure that when you're setting concrete, that your concrete does stay moist while it is, no matter how weird backwards that might sound. You do want it to stay wet while it's drying. You want a certain moisture level to stay there, or else your concrete becomes brittle. So
Okay.
we've been pressure testing all of our concrete and all of our solutions that we put through, because they have to reach certain housing regulations. But we've been going above and beyond most of those regulations. But just making sure that we're hitting A through Z and making sure that we're able to create something that's sustainable, cheap and affordable for people, but also has the potential to be really luxurious.
Yeah. And speaking of on the topic of luxuriousness, probably the question you get the most: how much does it cost? What's the cost to build one of these things? And is it a like price per square foot model, or how does the pricing work?
Yeah. Well, that's something that we've been learning as we've been printing structures. We think that we've got it pretty down. So this might change in the future, but we're thinking that we can probably print something around $100 a square foot. So usually average of like lumber and stuff, is averaging 150, 200, depending on what you're doing. But we're thinking to prepare a nice luxurious home, we're thinking we can keep around $100 a square foot. And, eventually in the next year, after we have some of our own little spots out here, and we have all the permits and all that stuff approved, we might start printing some places out here that people can visit, and we'll start, accepting orders. We've got a lot of people asking us now already to print them things, and we really want to, and we really want to jump on it, but we just want to make sure that what we do is the utmost quality, and that it comes professional, and that's going to be something that's really going to change the world. And we just want to be ready for that.
And how long does the concrete last? And is there some type of warranty or something that that you guys will provide to the end buyer of the products?
Yeah, that's a good question. That's something that we've been dealing with, is like learning how to create and make our structures permittable, and also make our structures insurable, so that way your house is insured. And we've been jumping through those hoops and learning how to create so that when we're able to present a house to someone and sell a house to someone, that we will have all of the um, moments thought of, and will be covered to make sure that it protects us, and it also protects everybody that is going to live in one of these beautiful homes.
Right. And how long do you guys expect a home to last?
Oh man, a total concrete home. I mean, it should last, at least last out, without your over your lifetime for sure. 100 years, no problem. Um, I've never, been around to stand or see anybody that made aircrete 100 years ago at the moment.
Right.
So, but definitely like monolithic stone structures and stuff like that can last thousands of years. So, depending on the quality of our concrete and the environment that it's in, these can be generational homes for sure.
Wow, that's cool. I like that concept of a generational home that is affordable and it was easy to construct, quick to construct. How long does it take to create a home, to 3D print
Yeah.
one?
So we've been estimating that for us to do a 4-bedroom, 2-bath home, to print the structure might take us about 2 weeks. And we are on the way of trying to figure out a way to mainstream the entire process, so that way we would be doing all the finishing and detailing stuff inside too. I'll always work with wood, and I think it's a real beautiful thing, especially accenting. So being able to provide the whole experience other than just the shell, is something that we really look forward to, bringing that artistic touch. We're not exactly sure how long it'll take us to completely finish an entire home. But at some point in time this year, out here in Utah, we plan to try to put up 2 of them. So by the end of this year, we should know what the flow is on how to create one full house that is sustainable, permitted, and completely ready. So that way we can continue bringing the service to other people.
Awesome. Yeah. And I'm sure as it progresses and the technology progresses and companies like Symbiotic 3D get log more hours, so to speak, I'm sure the whole thing will get quicker, because, in construction and in real estate in general, time is of the essence. Nobody wants to have those holding costs racking up and all of that. And I'm curious, like, because there's such an opportunity for 3D home printing to be, if not the answer, at least a answer to many of our problems that we're facing as a nation and as a global society, like, affordable housing scarcity, and just housing scarcity in general. We have a lack of housing here in the United States. As a realtor, I can speak to the fact that, especially in Miami, it's a very strong seller's market because there's just not a whole lot of inventory. And we also have a homelessness crisis in this country. Do you see 3D printing as the primary answer to those problems, or do you see it as sort of like a one aspect of the greater solution? What do you feel like the role of 3D printing homes is in those problems, in those issues?
Yeah, that's a great question. I think our role as a 3D printing company, in creating housing, is multifaceted, for sure. But I think that of the people that I personally know that work here and are very kind people, and I think that we really do want to help change the world and make it a better place. And I think that providing affordable homes and being able to do disaster relief homes, disaster relief in any form or shape, will be tremendous. And I think it'll be one of the main spearheads that we have going. And then of course, a lot of us being artists, is taking this in our artistic direction. But the forefront is definitely about homes. And I think that you're right. There is a huge housing shortage, and we also have tons of homelessness. And to be able to create something that is more sustainable and not as expensive can drastically change a lot of people's lives. And like I said before, the generation of people's lives, which I think is something that this generation is thinking more of. Is not just about ourselves, but things that are going to happen in the future. And doing all this logging and housing, and what we used to do, what they used to do 50, 60 years ago in housing, and having lead paint and asbestos, and like, let's just put it in everything. It's like we don't do most of that stuff now. And so to think about what we do now and what we're going to do in the future, we need to be focused on creating something that is friendly for the earth, something that's friendly for ourselves, and something that's going to last. And I think that this is the answer to a lot of those problems. So yeah, that we are on a mission, and we are slowly transforming, our little space here at the desert moon. And I hope that we eventually will branch out and change the world. And there's not a lot of people, like you said, the time that we've been spending. There's a lot of time. Not a lot of people are doing what we're doing. And there's a lot of R&D, and that happens while we're working. And so we want to make sure that we spend that time on ourselves and on our own money to move forward.
That's awesome. It's awesome and beautiful. Are there any limits? Like, ostensibly, could you 3D print a skyscraper or like a baseball stadium or something like that? Do you see that in the future? Or
yeah, I mean, it might not necessarily be made of the whole entire thing might not be made of concrete, but learning how to use different materials and doing the small 3D printing and making my own models. There's another good developer here. His name's Zach, and he helps make models, and learning how to do things on a small scale, and learning how to create supports for different structures depending on what your medium's weakness is. I think that we'll be able to print almost anything. Learning how to print, more rounded structures, creating a lid for a dome. If you just think about things in a more abstract way, just turn the top on its side, you can easily print within your parameters if you're to print a dome top sideways. But it's not going to be printed the way that it might not be printed exactly the way that's going to be installed. And so learning how to work with your medium is very important. And I think that eventually, you'll know how to print with glass, you can print with concrete, you can print with wood fiber or hemp fiber, which is, another avenue that we're trying to discover. There's so many little fingerlings off this giant river of 3D printing, and finding the one direction that we're going to follow, and has been really fun. And learning how to infuse all these other little things into it. I think we'll be able to one day completely have an automated home printing system that, you can help choose and design yourself, and someone sits down with you, and then you press go and everybody walks away and it does its thing. It'll print the windows, it'll print everything. So hopefully that's the future.
yeah, no, I think that, especially because I know that they're like NASA is one company, and other technology companies are looking into kind of what we were talking about before with like the on-site substrate printing and sort of sending a 3D printer out into space, and then somebody who in Houston or wherever just presses the button, and then it goes and it just builds the colony, so to speak, for the humans to then go inhabit on Mars. The applications from just like residential real estate go all the way up to that, to the edge of the galaxy, so to speak. And so, as is the case with any new technology, I'm sure that there are, like you mentioned, these finger kind of rivers of information and new ideas and discoveries branching off of this central hub. I'm sure there will be more new branches, not just of the technology or the substrate and the methods of creating, but also the styles and of creating, the styles of structures, the styles of architecture, so to speak. And I'm sure architecture in 20 years from now will look much different if you're an architecture student, in 2041 versus now. Your classes will probably be at least including some elements of 3D printing, I would imagine.
Yeah.
So, and I've noticed too, in kind of watching a lot of videos about 3D printing homes, that there seems to be a common element of architecture, of design in the walls themselves, where I guess you have two exterior beads, and then you have sort of like a zigzagging structure on the inside. What's the function of that design? Is it like an insulation thing? Is it a strength, like a structural integrity thing, or is it a little bit of both? Are there some other things involved that I don't know about? What's the function of that design?
Yeah, well, it's, all a part of the structural integrity process. So what we're wanting to create is, first of all, you're going to want to create a wall in 2 layers, because you're going to want some layer of insulation in between. Then therefore, if you create a double layer wall on the outside, it'll create more structural integrity for them to be able to support each other from collapsing in on each other. And there are a lot of different ways in design of filling the gaps, which is, would be called your infill. And, you can set your computer, so when we're creating a 3D model, you're talking about schools and schooling and architecture in the future. A lot of it is not going to be drawing anymore. A lot of it is 3D modeling on the computer. We spend a lot of time on the computer creating 3D models. And when you're creating a 3D model, you then have to put it into a program called a slicer. So a slicer is something very specific to 3D printing. And it's learning how to break your 3D model down into individual layers and how those layers are going to be printed. And so you can adjust your infill settings to create different types of patterns. You can customize your own patterns to create different integrity inside the wall to maybe make your structure more sound. But, there's a lot of complicated things, or a lot of variables to think about, whether, because if you're creating a concrete wall and there's an outer wall and an inner wall, if you have a beam that is made of concrete that touches the outer wall and touches the inner wall, no matter how much you insulate it, you're creating a cold joint there, where cold will transfer through the outside into the inside. So that's one of the reasons why I'm here, for the aircrete, and learning how to limit our infill and integrity, so it's easier for us to have a team come in and do all of the plumbing, all of the electrical, and install it right into the wall. And then we can come through, and whether your house is printed in 1 section or 17 sections, there's going to be parts where they overlap, and we're going to fill it with aircrete. So that way aircrete penetrates and is filled through every spot, creating a monolithic structure. And I think that is one of our strong suits in our wall integration. Other than some other stuff that I'm not going to mention about the inside of how to create different interiors. I know very few people are doing this, but we're trying to develop our own system, and it's a complicated endeavor doing this R&D, and some of the answers we've come up with we're not ready to put out to everybody yet, but learning how to print in a variety of different ways, I think, has broadened our mind to learn how to create these structures. And yes, basically what you were saying is these outer walls in your infill is what's creating the integrity of the building, and also your insulation, and how easy it'll be maybe for you after you do an infill, that's trihexagonal, and it's all these little triangles. It's going to be very difficult for you to feed wire through 20 different outlets when you're done at the end. So yeah, 3D modeling is the top of the game right now, and I'm trying to learn that more. We have some people on our team that are incredible at it. But yeah, learning how to actually create a 3D drawing and a 3D rendering, and when you break it down and slice it, how to create these perfect walls and structures inside. Um, it's very important. It's probably one of the most important parts of the building for it to hold its integrity. And yeah, we've come up with a couple different methods for it, and aircrete seems to be the way that we're moving forward. It's a really beautiful thing. Um, if you want me to talk about aircrete, that's probably one of my favorite things that we've been playing with. It's not something that we can print because of its consistency, but essentially you're using Portland cement and mixing it instead of just with water, but with foam, and you're creating foam with a foam generator, which most people can make at home actually. And you can use dish soap or certain types of foaming agents, but you're basically creating something that's kind of like shaving cream actually, and you're just mixing it with cement. And from one bag of cement, you're usually mixing about 3 gallons of water. You end up with about 3 gallons of cement, but with aircrete, you're creating 55 gallons of aircrete.
Because it expands, or?
Yeah, so you're mixing this powdered solution instead of mixing it in straight water and creating more of a mud. You're whipping it and mixing it with a foam that creates a large volume that's kind of like a soupy foam mixture. And when it hardens, those bubbles, depending on what type of foaming agent you use and the integrity of the bubbles, it's creating these hollow spaces of air in your aircrete. But you know, the circle is one of the strongest forms, so the integrity of the concrete is still very high. But for me to have a brick that's almost as big as my torso, I can pick up and move by myself very easily.
Wow, that's incredible.
Yeah.
That's just, I'm letting that sink in for a second. That's phenomenal.
Yeah, and you know, if you can apply certain sealants to it, you know, you can make bricks that float. And just the fact that we're able to create something that's so dense and hard, but it's so light, and it's also very insulating because of the air and the concrete. So to use it for the purpose that we're using it for, I think is one of the best uses. And I think it's going to be really revolutionary, and it can also help transform other different types of housing, like metal roof houses, stuff like that too.
Wow. That's a lot to think about. That's so in this slicing process that you're describing, I'm guessing, and maybe I'm wrong, correct me if I am, and you kind of mentioned, you alluded to like the wiring and all that stuff. I'm guessing that this slicing process is kind of, that's when you decide or design into the house where those wires, where the conduits are going to go, where the plumbing is going to go. How does all that work? Like, how does it work actually wiring and sending plumbing through the structure? Do you do it as you go? Do you do it afterwards? Or are some of these things, is it easier to have it on like the outside of the wall, like in the interior of the house, or is the idea to have it similar to a normal house where, you know, everything's interior and you have more of a seamless design? Yeah. What's going on with that, with all that?
Yeah. So, you know, depending on if we're creating the house, so far that things we've been creating are for ourselves. So, you know, we'll first create an artistically beautiful house that will actually print within our limits of cantilever. And then when we're in our process of slicing, we're going to start looking at the infill and the layers of how the house is going to be printed. So when we're thinking about that, I'm thinking usually about where our plumbing and all of our stuff will be, our electrical will be inside of our walls, to make sure that there's no infill in those areas. And then also, if we're going to be printing something, there might be a process where we'll work up to the bottom of the window frame, stop, create frames, put all that stuff in, work up to the top, and to make sure that everything is sealed in, and then do the rest of the building. That's kind of an experimental thing we've been messing with, other than what we've done traditionally is just do it all as one. So when you're looking at these infills, yeah, I'm thinking ahead of time before I'm even printing about where these areas are going to most likely be, and where they're going to be coming from, and trying to create as much space and ease of access for the electricity and the plumber. And then once it's printed, we're not doing the infill right away. So usually we'll let the structure completely cure and dry, and then the electrician and the plumber are actually able to get in between the segments of the wall and feed all of their stuff in between. And depending on what the client wants, we've been designing very special wall patterns and the way the walls are designed. So that way, if you install someone's kitchen and or someone's living room, and you have all of your electrical outlets and stuff like that all set up and ready to go, if they want a traditional mesa style home, we can go in and do everything mesa or cob and finish the concrete that way. Or the way we've designed our walls is we are able to insert, lumber and completely drywall the inside of a home and create it just like a standard American home would do. And you have your standard outlets and all of your plugs and electricals just as you normally would. So being able to provide something that has multiple uses, and we will most likely have a certain number of homes that we can easily produce for people. But I think the point is going to be for each individual house to be individual, to be special. And so a part of that design process goes into all of them. But it is, a procedural thing, thinking down the line of like the next crew that comes in when they're done, how to make it most easy and efficient for them, and the product at the end to look as professional and as luxurious as we can. We want to be able to provide people with a multi-million-dollar home, but we also want to be able to provide somebody with, cheap alternative housing that can house, millions in disaster relief and still be comfortable, still be affordable, and still be artistic. Even if you want it to be, it can still be cheap and artistic, just depending on the design.
So it seems like it would be like one of the limitations of 3D home building might be that, like, if you decide in a normal home, hey, we want to remodel our home and we want to put our kitchen over here on this wall and open it up and like do an open concept design or, things like that people traditionally will do with a normal home, and you just knock down some wooden walls and you tear it up open down to the studs and rewire it and everybody has a good time. It seems like with one of the limitations of 3D home building would be that it might be harder to kind of remodel or like move your kitchen over there, so to speak. And is that true? And also too, like what happens if there's a plumbing issue? Like if a pipe bursts in the middle of the wall, do you, after shutting off the water main, do you like tear open the wall and fix it and then patch it up? Or do you just like tear the whole wall down and reprint it? Like what's the I guess the optimal procedure there for dealing with stuff like that?
Yeah, these are great questions, man. These are things that we've gone over like tons of times, just because we run into some roadblocks ourselves, and also just thinking about like, wow, cool. Well, we made this hurdle. Like, what might be the next one? And yes, doing a renovation is definitely not going to be as easy as tearing down some drywall and tearing out some 2x4s. Is it impossible? No, not at all. Now, the thing that it's kind of a double-edged sword for me personally, because I am a carpenter and I do like to do a lot of my own work. So there will be certain limitations to the amount of personal work you can do to your home, especially like interior inside the wall. But I guess the other benefit to that is, if you are doing those types of things, most of the time you should be getting permits. And if you are, you should most likely be trying to find someone that is a professional and really knows how to do what they're doing. And so that way, at least you know that the integrity of our homes, if someone is going to be doing a repair, they're going to be someone that's licensed and is going to keep the value of that home. As I'm personally learning at the moment in this hotel that's from the 1900s, I've torn down 2 walls now and created some stuff. And man, to see the other stuff that other people have done before you, sometimes that can be just as challenging as trying to do the work initially. So that I would say that it is something that is a slight disadvantage, but also to the advantage of the things that you can design for yourself when you first think of the building are unlimited compared to necessarily the amount of money you would spend for someone to fabricate out of lumber. So yes, it would be very difficult to do some repairs. Now speaking about like if something was to happen, we've been designing certain types of systems so that your plumbing and all the electrical and stuff that are inside the walls and certain conduits are easily being able to be changed out if need be. That being said, the systems that we have in place are creating it so, and the wiring and everything that we'll be using will stand the test of time. But we will also make it so that if there is any faulty issues, because those kind of things happen all the time, that an electrician or a plumber is able to get in there and do their work that needs to be done on, your standard plumbing or housing that you would on a normal home.
So do you think, like, I guess going back to like the idea of, let's say a pipe bursts, let's say like take Texas right now, a lot of pipes are freezing, because these are homes that have never been winterized. And so you have pipes freezing and bursting all over the home potentially. So is that the kind of scenario where you would have like somebody come out and with a 3D printer, maybe it's a similar machine to the one that actually creates the structure. Maybe it's a little bit different, more specialized, but is that the type of thing where you have someone kind of come out and like patch it up? Or is it like tear it down to the foundation and rebuild it because it's it'll be easier or cheaper or similar cost and you might as well start new?
Yeah, well, I guess the cool thing that speaking in that specific circumstance, if we're having plumbing that goes all throughout the wall and it's feeding from your main water line and everywhere else inside the house, if you had multiple fractures for example, real life situation that's happening in Texas right now, you have 15 breaks in 15 different places inside your home. The PVC and our water lines that'll be inside in between the walls will be insulated, first of all. And then when they are put inside of the aircrete itself is actually going to create a complete concrete form throughout the entire wall of the house. So actually every single pipe will be wrapped in its own insulating concrete form. So it's insulated. It's not going to freeze to begin with or overheat. It'll stay its regular temperature, medium, average temperature of the environment that you're in. If you were to like build up way too much pressure or something, and it was to actually break the pipe itself, it is still then encased in a complete form of concrete that now continues the same conduit of the pipe of where the water originally was supposed to go. So would that cause problems over time? Maybe over 60 years, 70 years. If the water is leaking through the aircrete, it'll still keep moving through its formation, but for it to actually break inside that form, and especially with certain materials that we've been using because we've been considering the movement in California where there are earthquakes. So something like PEX PVC is able to have a little bit of movement to it. So we've been designing certain other systems and stuff that I can't really go super into detail about, but that are hosing systems, electrical systems that will not break. And if they, for some unforeseen thing that sometimes happens, we are able to you can actually go in there, drill out a section of the wall, and you could actually just cut out one section from one side and remove what you need to and mortar patch over it.
Okay. That's what I was kind of expecting should be the case, right? And maybe, I don't know if you think it could potentially get to the point where, I think 3D printing is the future in many respects. So maybe at some point in the future, pretty much every home has a 3D printer in it, and you have some type of scanning device, maybe using like a Matterport type technology where it's like, you cut out the hole, do what you need to do, like you said, and then it scans it and it prints you an exactly sized piece to just kind of put into the place and then mortar over it. So yeah, that seems like a distinct possibility and a kind of a good way to deal with those kind of issues. I'm curious. Oh, in addition to like adding on to this kind of discussion of like the fundamentals of building, is the foundation of the house, is it the same type of foundation that you would pour for a traditional house? And on that note too, is 3D printing of a home kind of limited to more or less flat terrain, or can it be used also on a grade as well?
Yeah, so right now, building regulation, we're building on a flat, normal slab that a normal house would be placed on. We haven't really thought about doing anything elevated yet. In the future, I'm sure that we will, and using pillars or pylons, but it'll definitely have to be something that meets building code. So right now we're just printing on, concrete slabs, and the angle factor at this moment, it needs to be relatively pretty level, which we can easily do with heavy equipment and stuff like that. But working with the machines and a company that makes the machines here, and some people that are branching out to sell and modify or make machines, learning how to make adjustments so that we can print on the side of the hill. And then, you're just going to have to work with your variable of how the structure integrates with your plan, or juxtapose your building to your angle or whatever you're printing on. I'm sure we can come up with some really creative and beautiful things. So, it's not necessarily a huge limitation, but it is an obstacle that we are conquering and working around.
Cool. So speaking of zoning, when you're building something, it has to be, whether it's 3D printed or not, it has to be code certifiable. It has to be, permitted by the local planning and, building and planning board, et cetera. Right. So what's the process of permitting and then ultimately getting that certificate of occupancy for a 3D printed house? What's that like, at least maybe in Utah where you guys are at?
Yeah, actually, that's what we're learning right now, actually, in Grand County. We're right outside Arches National Park. It's incredibly beautiful. But
yeah,
working with the county, Grand County, has been an interesting process. And they themselves, and a lot of other places that we've talked to, a lot of other cities that people have asked us about stuff, it's kind of like a gray area for them. They're used to looking at concrete forms or rebar reinforced concrete. So, we thought about going down that road of, certain rebar to like kind of meet a standard, but doesn't necessarily always need it. And so right now there is no road. We are paving the road, and there are a few other companies that are trying to do this as well. And cheers and hats off to them for helping create this and making it easier for everybody, because it is kind of a gray zone right now. So that's why before I was speaking about having our concrete pressure tested, so people are able to see how much weight and wind can this actually sustain. And all of that is part of the permitted process. When the house is done, it looks like your standard concrete house, other than if it's not finished smooth, you can see the lines of it printed, which is sometimes kind of cool.
Yeah. No, go ahead.
Yeah, I was just going to say, it's kind of a gray zone for them right now. And we're just working side by side with them. And we just want to make sure it's just as safe as they do, if not more safe, just because we want to provide something that's going to last forever.
Right. Yeah. And are there any states or municipalities that you know of that are particularly friendly to 3D printing? I know that the first permitted code compliant 3D home was created, I think, last year at least in the US. It was the first in Austin, I believe it was.
Yep.
And they showcased it for South by Southwest.
Yeah.
Are there any, I mean, you know, and I know Texas has pretty strict building and code, you know, I don't know, compliances that, you know, you have to meet. Are there any states or municipalities that you know of other than that are particularly open to it, or?
No, not that I know of at the moment. We haven't really been trying to reach out yet because we're like ready to fire the gun, and we just want to make sure that when we do, it's go time. But yes, wow, I can't even think of their name now that you mentioned it. But I follow them. The company
Icon.
Icon. There you go. Yeah, Icon. Yeah, they have a similar style printer, and they've been printing some really amazing stuff. And to see that it's permitted and it's able to be there is, kind of like a golden ticket. It's like, if one place starts off, it's very easy for other places to start following suit, or at least having a basis to go off of and maybe make minor adjustments to the law. But the fact that it's happening, that's kind of our blueprint as of now.
Right.
I know in Belgium stuff, they're doing stuff and printing, but for here in America, in the United States, that's kind of like where the first thing has been happening. I know Icon isn't the only one doing it other than us, but there's very few people that are really pushing forward and making strides. And yeah, I think that's kind of our blueprint to go off of right now. And I hope that states, like I mentioned in the beginning, Louisiana, Florida, for that disaster relief, Texas, even now, other places start to use that model so that we can help people, because it's needed.
Yeah. So in the same sense that, like, it seems like what you're describing is more or less like an adoption curve in terms of like the relationship between the 3D home builders and the municipalities and therefore states, in the same sense that there's this kind of adoption curve that, like, as it progresses and people kind of see, hey, this actually works, and, we're going to allow it here, and now it's allowed over there. And as a result, they have those case studies, and over there, they're going to start allowing it in the same sense that it kind of becomes more accessible as more examples have been created. Do you think that as things progress, that and these companies, including Symbiotic, are kind of moving more to scale and constructing on scale? Do you think that the cost to manufacture will also kind of become more feasible as things are moving to scale like that, or do you feel like it's somewhat of a more consistent pricing structure, and you guys are kind of front loading a lot of like the R&D costs and kind of eating that cost up front, and then putting out a product that's already sort of more accessible at cost, and doesn't have a lot of room for decreasing in price later on? How do you feel about that?
Yeah, that's a great question, man. At this moment, we take a lot of the upfront R&D costs, even just printing, like we've got a ton of water fountains, beautiful water fountains that we're using for ourselves and our property. But, there's a lot of just research and development and like learning how to use this machine. At the way that we're developing and using the machine now, using concrete, I think that the price long term will usually probably stay about the same. Now, once we start working and moving into a place where it's more of a geopolymer type of situation and being able to create our own polymers in the area and the environment that we're in, I think then the cost will be able to significantly go down. There will be a lot less shipping and handling and, ordering materials from places that might be hard to get in your local area. So that's kind of why we have our heads in that direction, so that it's more sustainable for the planet and it's more viable for the consumer. But for right now, I think at the way concrete is and the way Portland is, Portland cement, and the way that we're creating our mixture, I think it'll relatively stay pretty much the same. I think the only difference will be is like, your shell of your house, depending on the square footage. I think the price per square foot for the shell will always relatively stay the same if it's going to be concrete. The type of finishing you want, will range drastically. But once we move into more of a geopolymer type of thing, people can, I think there will be a varying class of what people want and what's most easily feasible for them. And the price alternatives, I think, it'll create a nice range for people.
Yeah. So in that same kind of vein of and just so we're everybody listening and myself low key are clear, the geopolymer is what you describe of like using the kind of the on-site materials and creating like a substrate out of what's already there, right?
Mm-hmm, yeah. So a geopolymer would be basically, a mixture of minerals from the local environment that will create a certain type of polymer. So we're looking for a polymer that's really hard, like concrete. So yeah, essentially we're trying to create. You're kind of like mixing you're baking like a little cake, and you're mixing all these little things together, trying to figure out that perfect consistency that you want from what you've got around you.
Got it. So it would seem that just based on like using that principle of like on-site materials, creating this geopolymer, it would seem like some areas may be better suited towards that style of 3D home building. Do you feel like that's the case? Or do you think that different areas, it's a matter of research and developing whatever that substrate is, whatever the mixture is in, I don't know, North Dakota that works best versus in South Florida?
I actually think it'll be, I guess you would say, a futuristic or a different version of what most of us have already witnessed before in the past. When you travel just around the United States and you go to New Mexico and look at ancient people's houses, and they have the Pueblo houses and stone, natural mesa stone stuff. And then you go, to places like New Hampshire, and there's natural granite rocks or houses with moss. And, it all depends on the environment. And I don't necessarily think one will be better than the other. It'll be better in certain circumstances for certain applications. But I think the fact that it comes from its natural environment and the resources that are already provided in a natural state are there to support that natural state. So I think that it'll create these beautiful differences. Could we print the same house? Most likely. Will it look different, feel different, act differently? Definitely. But I think it'll be part of the artistic beauty that is creating something that's natural from its place. It gives it a certain flavor, if you will, or character.
That's super interesting, super cool. So at the end of the day, we're talking about a consumer product, right? It's a home. So what is the consumer experience from A to Z? And in terms of like, if somebody decides they want to get a 3D printed home, how do they start? What is that process like? Are they involved in the process of designing it? And if so, how? And like how much customizability is there?
I would say right now at this very moment, the open-ended of the customization is unlimited. Now, does that affect the budget? Most definitely. We will try to create some beautiful artistic houses that people can kind of choose from, kind of like you would, if you go to a new community. They will have, 6 model homes. So we might create a little bit more diversity than just 6 that have different feels for different suitabilities, for a large family or a small family or an individual. But I think our options will initially kind of cover a lot of bases for people and provide something that's beautiful as well. And so if they want to choose one of those, then we go through that process of picking that home and maybe some of the other features that they might want if they want their kitchen, like you said, on one side of the room versus the other side. Those are something that we can make relatively quickly in the 3D model. And then we just start printing, and and then do all the finished work, and we'll finish their home. Now moving into a more customizable home experience, um, that's something once we kind of get our feet going and we're actually printing a few houses a year, if not much more. Um, we will offer that to certain clientele that want to spend the money and the time to sit down with someone and actually design a 3D model home. But we want to be able to provide something that's easy and beautiful that someone will really enjoy. And we also want to be able to sit down with someone and create the home of their dreams.
Yeah, I think that that's such a cool aspect of it. The ability for the end consumer to kind of be involved, similar to how, like, if you hired an architect and you wanted to be involved with the architect, at the end of the day, the architect is the one who's going to like come up with the plans and make sure it works. But you could be like, hey, we want kind of like our kitchen to be over there, and we imagine having the floor plan be like this, and like that kind of element, I think is really cool that, you can be involved in that way. And I don't know if it was Icon or if it was another company that actually had like a AR experience, like like an augmented reality, like, you put on the goggles or whatever, and you like create your home inside of this virtual world. And then, boom, it's able to be a reality. You could be sitting in that living room 2 months later or whatever, after you virtually created it. I think is just super cool.
Yeah.
And one thing that I feel like I haven't really heard a lot about in this space is, and to set this up, like we know that there are people on site, right? It's not like we're not at the point where you just deliver the crate and press the button, but maybe it's moving in that direction. But I feel like there has to always be some element of like, there has to be someone on site. How does that relationship play into the behemoth of the National Home Builders Association and people's concerns over automation, not only automation decreasing the amount of jobs, but something like 3D printing? I would think there would be less people on a 3D printed home job site than on a traditional job site. Is that the case? And like, how do you guys plan on sort of co-mingling with the, if at all, with the builders associations and sort of that like workers' rights element of the space?
Yeah, that's a great question, because I'm a carpenter and I don't want to put myself out of a job. So,
right. Yeah.
I love working with wood, and I always will. And, learning how to incorporate those two, specifically for my home that I'm going to be building here, it'll be half 3D printed and half large timber frame construction. So learning how to fuse the two elements really creates a wonderful sense of beauty. And but for the, like you said, the job market and other framers, that's kind of the only thing our printer takes away, is the framing of the home. And we, like you said, it is not completely autonomous yet. And so to use people that have framing knowledge actually really comes in handy when I'm looking at a wall and trying to decide its integrity and how this wall is going to flow with maybe the next part of the home. I don't think we're necessarily going to be taking away a whole lot of jobs in that degree. I don't think we're going to be pumping out that much more housing. And there will always be a need for timber frame houses or, metal framed houses like barn dominiums and stuff like that. But yeah, I think it's always going to have that sense of someone keeping an eye, even if it's us creating a computer system to watch the machine. Somebody needs to be there to regulate the machine and regulate what's going on and the services that the machine are watching. Because if it's going to send you alert that something's wrong, someone needs to receive that alert. So there will always be a little bit of oversight over the entire operation, and being able to provide people with that job instead of doing a large lumber crew through framing. But then we're able to provide cheap and affordable houses and bring on large teams that do plumbing and electrical and, traditional wood roofs if people want wood roofs, and stuff like that.
So do you think that some of these construction companies can or will try to implement their own 3D printing as time goes on? Like kind of like in the way that, well, I guess like if Blockbuster had actually bought Netflix back in the day, if they had seen that coming, like, do you feel like it's a similar dynamic where, because I know there is some resistance from some of the home building like associations where they see this as this incoming hurdle, and the natural tendency I feel like with large organizations like that is to resist rather than to sort of become one with the incoming trend. Do you think that it will be feasible for some of these large home building companies to start implementing their own 3D printing, or is it just too specialized of a trade and they're too unwieldy of a large organization that is, maybe doesn't have the resources to offset like a R&D team to go out into the desert of Utah and figure it all out because it's not quite profitable yet for them. How do you feel about that? I mean, I know that there's an element of like, it is safer. Like 3D printing is guaranteed, less harm can, potentially occur on a site, I feel. So that maybe is one sort of like piece of the narrative. But the other, the converse side of that is that, these home builders are probably going to be like, well, these are plenty of great, jobs or union jobs in some cases. So I feel like there's already a bit of resistance and could be more resistance to it. Maybe insofar as we see lobbying on behalf of these home builders or even localized efforts to try to block it from like zoning and planning departments. Or do you think that it's in their best interest to try and like adapt and do their own form of 3D printing?
Oh, well, I definitely don't think that major traditional timber home builders, Fortin, or other ones, I don't think that they're going to try to move forward into 3D concrete printing or 3D printing in general, just because it is such a, it's kind of like people that skateboard like skateboarding and people that like to snowboard like to snowboard, but snowboarding and skateboarding seem very similar, but they're also very different. And, you need a whole entire different set of equipment, skills to do one versus the other. So I think that the larger companies, I don't think they're necessarily going to want to move over. I think that will maybe seed other people that go out and start their own specialized 3D printing company. That doesn't necessarily have to be concrete, but I think that there will be other people as time goes on, and ease of information and access to these machines. I think there will be a few more. I don't necessarily think it'll get to the point where it's kind of DIY. And I think that will be one of the benefits for us when we are going against certain municipalities, like you said, and against the housing association, because I think there is already a little bit of pushback, and I think that's expected. This is changing and transforming everything, and there is I could see how there would be a fear of the whole like they took our job type of thing. But I think that for them to work together in like a symbiotic way, I think is going to be huge. And I don't think, and I've never witnessed ever in history where all of a sudden everybody just decides to do everything one way. There will always be people who want a traditional lumber framed home. There will always be people who want a stone home or a brick home or a 3D printed home. So I don't think that we are here to take over. I think we are here to claim our piece of the pie and an option for other individuals and people. And yeah, I think that the municipality, as time goes on, I think that they will start to become more lenient and more understanding. And you know, we want code. You know, we want to build something that is not only beautiful, but it is structurally safe and sound, and it's going to last a lifetime. And so we want them to create codes for us, and we want them to create building restrictions or certain things that help make sure that things are safe. We just don't necessarily want to jump through a lot of unnecessary hurdles, which hasn't happened yet. So far, everybody's been just very objective and just looking at it like, okay, this is something we've never experienced before, but it seems really awesome. And, you know, let's just try to like go off of what we know. So the fact that Texas is starting to do something, it's a little bit more of something we can go off of, because we don't necessarily fit the building codes of your traditional brick and mortar home, because we're not necessarily brick and mortar. So yeah, it's been an interesting journey, and I think over time it'll get easier. And I think over time there will be seeds that sprout, and there will be other 3D printers and other people that print homes. But I think that, you know, your traditional housing market will stay strong, and your timber frame home will still stay there. There is a need for it, and there's also just a beauty in it too.
Yeah, definitely. So how much does one of these machines cost, roughly?
Well, that's quite the question. I can't give you an exact quote, actually. I'm not one of the owners of Symbiotic, and there's also something that's being born, that we will actually eventually be selling printers ourselves. So I would just say stay tuned. Take a look at our website, and stay up to date with our information, because it is a market and something that we do want to provide people. Like I said, I don't necessarily think it's going to be a DIY situation, but for someone to be able to, a company to be able to buy a printer and be like, hey, we want to, you know, rock this area, you know, or we want to provide homes in this area or for our community. You know, we can have trained specialists teach them how to use the machine, how to operate them. And I think that is an important part of the process of the growing. We don't want to be the only ones doing this. It's beautiful that other people are doing it, and to like feed each other and kind of like have that drive, so that we're always pushing to create a superior product, you know?
How much open sourcing is there in the space, or is it a lot of like proprietary information with each one of these companies? And by the way, backing up for people listening, I'll put the link to you guys' website in the description for everybody to check you guys out, which they definitely should. But like back to the question, so are people kind of like sharing like, hey, we just tried this new method of creating a substrate and it seems to work really well, or it seems to be horrible? Like, is there any sharing of that kind of stuff in the space in an open source way, or not so much? It's more like everyone's kind of trying to create a proprietary system and come up with the best, and that way they have the better product, which I'm guessing it's more likely that.
Yeah, it is definitely leaning towards that. The one thing that I have to say that's really beautiful is there is this huge surgence of, I don't know exactly what you would call it, but kind of like eco homes, where a lot of people are trying to create communities, or community centers out of natural materials. And the wealth of information that these people that sometimes are just, you know, mothers, daughters, fathers, brothers, they're not like some special trade skilled person. They just have a passion for creating something that's natural and living outdoors. And the information that community, the eco community, shares has been huge. And I've definitely used part of it. That's how I learned Aircrete, Dome Gaia. They're a big proponent of that, and they put a lot of their information just out there on the internet for free, that anybody can create their system.
Who is it?
Dome Gaia.
Dome Gaia. Okay.
Yeah, Gaia. Yeah. So now in the 3D printing world, um, just the machine itself is complicated enough that I don't think that people are just going to be willy-nilly making their own and using them. So most of the people that are designing either the geopolymers or the way that the system operates is definitely a proprietary, like licensed kind of hush hush thing. Um, even in the way that we acquired our printer and some of our partners are acquiring printers, it's definitely a very hush hush like, and it's also continuously always developing. It's like the printers that we saw a year ago, 2 years ago, compared to the printers that are coming out right now, are totally different. And I think it's going to continue being different for a while. I think eventually, kind of similar to the mini model filament printers, that there will be a style that people move towards, whether it's like a Ganter style printer or I can't even think of all the names actually because there's quite a few of them.
There's a lot, yeah.
There's a lot, and in the 3D printer, the small world has been influencing the big world in a big way. And so, learning how to create something that's maybe more efficient, like you said, if you're printing on a hill, a printer that will print better for that, or if you're printing on a line, or I think that there will be a few different options that come out, and it'll eventually be kind of like the main, depending on what you're trying to accomplish. Like if you were to choose a tank, or if you were to choose offensive or defensive, there's going to be these different proponents that are good at certain individual things, and I think people will move towards whatever is more suitable for them. But I think that the underlying technology and the things that make each of them specialized and unique will definitely be owned by the companies for sure.
What about the other elements of the house, like the windows, the doors, the flooring, lighting fixtures, kitchen cabinets, counters, all these things? Can these things be 3D printed on site as well? I know that you guys are right now in the more in the realm of focusing on the aircrete, but theoretically speaking, like, are we moving towards a future where those other elements of the house are going to be 3D printed on site? Or do you think that that's not a viable path forward, that it's just too complicated or potentially too costly to source all those different types of printers or what have you?
Yeah, I think at the moment it's not viable just because of the amount of mass of material that you need and the speed and productivity of our printers. Even just some of the stuff that I print with PLA, which is a type of plastic. I mean, I can print some small stuff that'll take 24 hours to print. So for you to print 100 light fixtures in someone's house, it's going to take you a long time. So I think as the technology develops, we'll definitely be able to accomplish those things, especially in the mold of like creating different types of plastic and metals and metal alloys and stuff like that, that we'll be able to move forward with that. For example, there's actually this really interesting recycling project I've been working on of, you spoke about Blockbuster, is VHS tape. The reel that's inside those tapes is magnetic, and it also conducts electricity, and you can also turn it into filament to 3D print with. So I think as ingenuity and more people get access to this thing, even the small printers, that we will get to that point that everything will be 3D printed. Will it be printed on site? That might not necessarily be a thing, but will everything be printed? There is a chance that everything is printed or molded. I mean, most things are, especially like, castings for like fittings, like bathroom fixtures and stuff like that. A lot of it's cast mold. So depending on how fast the printer is compared to mold, will determine whether or not they move in that direction.
Yeah.
But for us, even for us right now with concrete, we're learning how to create, building furnaces and tubs and heating systems into the house with concrete as we're printing the home. So yeah, I think that, I mean, even just learning how to do that in the way that we've been applying it, I think eventually we'll be able to print most things already.
Yeah, you know, it's such an interesting space because it really does seem like not even the sky is the limit. The edges of the multiverse are the limit, and how far can science take us in all of these things? Because, you know, at the end of the day, I mean, I could see a model, I could see a business model where, you know, I won't say symbiotic because I don't want to, you know, to foist anything onto what you guys model. We'll just say Jake's 3D Building Co. Could come up with model homes that are infinitely customizable. You go into your augmented reality world to create it, and then you have your site where it's going to be built. It's built, and then even as now, you can kind of go online and find these different files that will print different things with your, you know, consumer 3D printers. In the future, perhaps Jake's 3D home building, you know, you have every single little piece of the home is on the server, where maybe it's a subscription model or something. You pay a yearly fee to be able to access any of those files, you know, for a small fee, and print anything that might need to be replaced, or if you want to add on to your home, or, you know, things like that, where you can just expand as you go. Or if you want to, maybe going back to the remodeling idea, you can kind of just customize your house as you go, and print these, you know, infinite array of things to complement your living style, and your home itself. And that could be a whole industry in and of itself, is like that, that post build sort of subscription to all these things that you can print and add on to your home, or the surroundings of your home. Like, hey, you want a planter that matches your home, that like looks like it was designed by the same architect. Boom, here, download the file for 99 cents, you know? Do you see that as a possibility or a viable thing? Or do you think that, I mean,
Oh
you're,
yes.
you have,
um, even right now, a lot of that possibility is possible, like through mini 3D printers, depending on all the different plastics or wood filaments you're able to print. I mean, I print things for my daily life every day. You know, I'm printing things to hold my cards, or printing hydroponic cups to grow more vegetables for our community, or pen holders or battery holders. I think that in the future, if we can start to learn how to print with different types of metals, different types of alloys, different types of geopolymer, that yeah, exactly. In the future, it will be a almost a subscription type of thing, kind of like when you know, are on Thingiverse or a couple websites online for 3D printed formats. It's an open source where all these people create these things, and you can either purchase some of them or some of them are free, and you can sit at your home and customize your home to your heart's desire. And you'll be able to print anything. Even if you want to, there will be kind of like a developer interface that, if you're familiar with 3D modeling and 3D printing, you know, you can go into the developer application and, you know, maybe create your little book nest in the corner, or, you know, create the little man cave that you wanted to make, or whatever, you know, outdoor, a beautiful garden shed. And people can start to like really customize and make whatever that, you know, like you said, it's like the limits are going to be the edges of the human imagination. Especially once we can learn to work with different types of material, then, you know, our limits are physics and what the material can actually do for the application that you're trying to use it for, and whatever your imagination can perceive or create.
well, I appreciate your time. I know I've kept you way longer than originally anticipated. It's usually how it goes with you know, very interesting interviews. I shoot for one thing and then way exceed any imaginable time of what I thought it would be. But hopefully people have enjoyed listening to this. And before we get to where people can find you. And of course, I'll put those links below along with the Symbiotic link and all. I'll end it on one kind of fun question. When will I be able to, from Symbiotic 3D, when will I be able to order my 3D printed Hobbit house?
Okay, great. So we're projecting that next year, if you want to buy and create an amazing, beautiful home out here in Utah, that will be a reality. So we are pushing ourselves physically and mentally and spiritually as much as we possibly can to continue creating the vision that's happening here. And yeah, that is the goal. So we are working tirelessly to create that a reality, and I think it will be.
Awesome. So 2022 Hobbit House coming at you. So well, season 3 of the Jake Fletcher Show, we'll do a tour of my Hobbit house. So yeah. Awesome. Awesome. So Brandon, where can people find you online if they want to follow you?
Well, you can always find Symbiotic 3D on our website. If you personally want to find me, you can look up Duende Build. That's our art company and fabrication. Or Duende Build. We're on duendebuilds.com or on Instagram at duendebuilds, or also Bello Woodworking. Both the companies are out of Florida. If you need any amazing woodworking or some amazing cabinetry built, reach out to the crew. We love what we do. The art is kind of like what feeds our souls, yeah, I would say you can reach me on those 2 places or check out Symbiotic 3D. To keep updated with what we're moving forward in the future. And if you want, your 3D printed home, that would be the place to check.
Can for the people who are maybe they're driving and not able to check the comments or the description, can you spell that for us?
Oh yeah, of course. Yeah, Duende is spelled Duende, build, Builds. And then Symbiotic, Symbiotic 3D. You can find both companies on Instagram, and Bello Woodworking is BELO and Woodworking.
Perfect. Awesome. Well, thank you so much, Brandon. I appreciate your time once again, and really looking forward to watching you guys build some homes and getting to see one in person someday, hopefully once this pandemic is over and I can get on a plane and come out to Utah and check out what you guys are doing. So thank you so much for your time and thanks for the information and the interesting conversation. I really appreciate it.
Yeah, no problem, brother. It's good to talk to you. I know it's been a long time since I've seen you, but yeah, thanks for having me on, and it was great to chat for a little bit, and look forward to having you come on out, and even if you just want a vacation and hang out, but eventually, hopefully, I'd love to build you a really artistic little Hobbit style den.
It's going to happen. I'm saying it right now. I'm putting it in staking my flag into that earth right now. So my 3D printed flag. So thank you so much, man. Definitely good talking to you as well. And thank you guys, all of you out there listening and watching. This has been a fantastic episode of the Jake Fletcher Show. Make sure to hit the subscribe button below. Go ahead and give us a thumbs up by just gently tapping that like button. And don't forget to share this with any friends or family or people that Hobbits included that you think might enjoy having gotten all of this great information straight from the source. So thank you all for listening, and we'll see you on the next one. Peace.